My name is Ogechukwu and I will be talking about arsenic toxicity. The diagram shows the levels of arsenic in different parts of the United States. Arsenic is most commonly found in the groundwaters of the Southwest. Parts of New England, Michigan, Wisconsin, Minnesota, and the Dakotas. Properties of arsenic. Arsenic is derived from Greek word arsenikon, meaning yellow or pigment. It occurs naturally in sedimentary rocks and ores and is emitted into the atmosphere by weathering, volcanic eruptions, and anthropogenic activities. Human activities such as smelting, use of pesticides, and coal-fired power plants also cause arsenic release. Arsenic is a metalloid, and so it has both metal and non-metal properties. Because of this, it can exist in multiple oxidation states and can form a variety of compounds. These include arsenic trihydride, which is formed when arsenic is exposed to an acidic solution in the presence of a strong reducing agent, such as zinc. Another compound is arsenic trioxide, which is a lethal poison that exists as several forms in nature and is the oxide of the element. Other chemical compounds include calcium arsenate, lead, hydrogen arsenate, arsenic acid, arsenous acid, copper 2 acetoarsenate, dimethyl arsenic acid. Arsenic occurs in a trivalent form called arsenite and a pentavalent form called arsenate. Arsenite is much more toxic than arsenate because it has the ability to inactivate multiple enzymes involved in cellular energy pathways. Uses of arsenic. Previously, arsenic has been used to commit murders because it resembles white sugar. It is odorless and tasteless. It has been used for weight gain because it enhances nutrient absorption, used to treat skeletal problems and anemia, and also used to increase physical strength. In the form of acetoarsenite, it was used in pigments to color wallpaper. In the form of gallium arsenide, it was used to manufacture glass and alloys because of its semi-conducting properties. In modern times, it is used to induce remission in patients with acute leukemia because it induces apoptosis by releasing apoptosis-inducing factors. It is used to treat diseases such as asthma, rheumatism, syphilis, and hemorrhoids in traditional medicine. It is also used as an analgesic and anti-inflammatory agent in industries. It is used to manufacture pesticides, fungicides, insecticides, wood preservatives, and cotton desiccants. Arsenic is also an essential trace element in the nutrients of some animals, so it's added to animal food. Routes of exposure to arsenic. Arsenic is mobile within all environmental components. It exists in air, water, and soil. It occurs in seafood in the form of arsenobentane and arsencholine. This causes increased arsenic levels in the blood. Intake is higher from solid food. Arsenic enters the food chain from agricultural products grown in contaminated soil, and eventually it works its way up to humans. Routes of entry into humans include inhalation, absorption through the skin, and ingestion. The major site of absorption is the small intestine at a pH of 5. The arsenic undergoes biomethylation to form monomethyl arsenic acid and dimethyl arsenic acid, 50% of which is eliminated in urine. Residual amounts of arsenic accumulate in keratin-rich tissues such as nails, hair, and skin about 14 days after ingestion. Properties of arsenic and impact on toxicity. Inorganic forms of arsenic can be methylated to form monomethyl arsenic acid and dimethyl arsenic acid, which act as tumor promoters and co-carcinogens. While arsenate is a phosphate analog that interferes with phosphorylation, Arsenite reacts with sulfur groups of proteins and inhibits biochemical pathways. In blood, arsenate is reduced to arsenite. The most toxic form of arsenic is the gas arsenine, followed by arsenite and then arsenate. Both arsenite and arsenate occur in solution. The arsenic bearing minerals are non toxic because they are insoluble. Adverse health effects. Arsenic is highly toxic. 1/10 of a gram can lead to death. Neurological effects may develop as soon as a few hours after ingestion. Long-term effects are highly variable and cause skin and lung cancer, cardiovascular diseases, and neurological effects. Arsenic causes neurotoxicity by changes in cytoskeletal protein composition and hyperphosphorylation. A lot of its adverse effects is due to inactivated enzymes in cellular energy pathway. Chronic exposure causes health effects in 3 stages. Stage 1, weakness, loss of appetite, nausea and diarrhea characterize this stage. Stage 2, conjunctivitis, inflammation of the mucous membrane, skin lesions, and mild bronchitis. And final stage, peripheral neuritis, depressant effects on the bone marrow, erythropoiesis and myeliopoiesis characterize this stage. The worst form is severe arsenic poisoning, characterized by numbness, tingling, nerve cell degeneration, paralysis, atrophy of leg and hand muscles, and death. Arsenic has mutagenic effects. Both arsenic 3 and arsenic 5 inhibit DNA, RNA, and protein synthesis by replacing phosphate in nucleotides during DNA synthesis. They also affect DNA repair systems. Arsenicals can cause damage to DNA due to oxidative mechanisms. They display clastogenic properties by their ability to induce micronuclei, alter sister chromatid exchange, and incorporate into the DNA backbone. Arsenic causes induction of cancer of the skin and lungs. Arsenic is also linked to development abnormalities, low birth weight, malformations, and fetal death. Some biomarkers for arsenic-induced oxidative stress include DNA damage, lipid peroxidation, redox enzyme activity, decreased antioxidant defense levels. Arsenic is genotoxic. Its exposure leads to various types of DNA damage. It also interferes with DNA methyltransferase. Mechanism of arsenic adverse health effects. Arsenic is taken up through food and is readily absorbed in the gastrointestinal tract. Sodium, potassium, or magnesium arsenite are readily absorbed in the gut and lungs and also through the skin. The fate of arsenicals in the body depends on their chemical form. Some of the compounds such as arsenobentane and arsencholine, which are present in fish, pass through the human body unchanged. After absorption through the gastrointestinal tract and lungs, arsenic moves into erythrocytes and is bound to the globin of hemoglobin. Arsenic is able to be transported to other parts of the body through the bloodstream and can be distributed to various tissues. The tissues with the highest concentration of sulfur groups, such as the skin, hair, and nails, will have the highest arsenic concentrations. Inorganic arsenic undergoes biotransformation in the liver. Here, arsenic 5 is reduced to arsenic 3, and then an oxidative addition of a methyl group occurs. The methyl group comes from S-adenosylmethionine, SAM, and glutathione acts as a reducing agent. After metabolism in the liver, you get MMA and DMA. These react less with the tissue and they are readily excreted in urine. The major source of toxicity for arsenic is the intermediates that are obtained from the reduction or methylation process that occurs in the liver. These bind firmly with thiol groups of proteins. Arsenic methylation occurs less in men than in women, especially during pregnancy. It is also lower in children. Case study: Arsenic and pregnancy in Bangladesh. This study was done by a scientist called Raman and some other scientists. The researchers evaluated the association between arsenic exposure in pregnancy and causes of morbidity during infancy. They assessed arsenic exposure by measuring the concentration of metabolites of inorganic arsenic in maternal urine samples collected at gestation at weeks 8 and week 30. They collected information on fetal loss, infant death, and respiratory tract infections in infants. They found that the arsenic concentration of the water that was being drunk by the pregnant women exceeded 10 micrograms per liter. They also found that the risk of infant death and fetal loss increased significantly with arsenic exposure during pregnancy in a dose-dependent way. They believed that arsenic affected the T-cell subpopulation in women and the maturation of normal immune effector cells. They also believed that the mode of action of arsenic involved oxidative stress, interference with the hormones glucocorticoids and estrogen, and it also affected DNA methylation and modulated signal transduction pathways. A combination of all these factors is said to have affected fetal development. It was proposed that these associations were caused by an increase in infectious diseases due to the effects of arsenic. The study concluded that arsenic exposure during pregnancy is associated with increased morbidity due to infectious diseases during infancy and also fetal death. Essentially, they believed that the mother's exposure to arsenic led to an increased rate of miscarriages and increased health problems in their infants that survived. Economic costs of arsenic contamination. At high dosage, arsenic disrupts the fundamental functioning of cells in numerous organs. There are great concerns about the effects of arsenic on health. Chiefly the presence of arsenic in drinking water and also indirect exposure to arsenic. The economic significance of arsenic toxicity includes loss of income, medical expenses to treat illness, reduced crop productivity, death of wildlife, soil and water contamination. Arsenic contamination is of great concern in places where majority of the population depend on groundwater for drinking, cooking, and irrigation. Ways to minimize risk to human health. There are different ways in which humans can be kept safe from the effects of arsenic. Some of these include use of an alternative water source if the arsenic level in the surface water and groundwater sources exceeds 10 parts per billion. Use of personal protection gear to prevent exposure to arsenic containing sawdust. Gear includes dust masks, gloves, and protective clothing when using arsenic-treated wood. Hand washing should be encouraged to reduce the potential exposure of children to arsenic in the soil, and also discouraging hand-to-mouth activities and children playing in soils contaminated with arsenic. People working in factories that produce fertilizers, pesticides, glass, copper, or lead smelting industries are at high risk of contaminating their cars and their homes, and so they should take precautions. The government needs to provide updated information on the levels of arsenic in certain areas so that people can take adequate precautions. The federal government can also take several steps to protect humans from arsenic. This includes setting limits on the amount of arsenic industries can release and restricting the dose of arsenic in pesticides. The EPA has successfully banned inorganic arsenic in 1993, while organic was banned in 2009. In places already contaminated with arsenic, the government could put arsenic treatment plants, which, although expensive, will be able to save people from the effects of arsenic. Thank you.